All right, today we are learning about rational numbers. Let's think practically. What does it mean for something to be rational? It makes sense, right? Or it is something that is clear, easy to identify, rational, right? When we talk about rational numbers, we're talking about a number that either has a terminating decimal. So what does it mean to be terminating? That it has an end, right? It stops. 3.2, 4.1, 6, a whole number. Or it has a repeating decimal. What does it mean to have a repeating decimal? It goes on and on with a pattern. So I might have a 6, 7 repeating. Okay, those are rational numbers. An irrational number, then, is a number that does not terminate, does not repeat. It just goes on forever and it has no pattern. That's an irrational number. So that's in a nutshell what they are. Now, you've got a section here that says, show that the number is rational by writing it in this form. Well, what is that? A over B. What is that? What do we call that? A starts with an F. Fraction. Yes, it's a fraction. A over B. So what do they want us to do? They want us to write these terms, these numbers, as fractions. All right, so let's do it. How do I write a whole number as a fraction? 6 over 1. Now, in number 2, the reason that this is not in A over B form is because my negative is not attached to a number. I can either attach it to the numerator or I can attach it to the denominator to make it rational. Either one of those answers would be acceptable. Now, number 3 is not a fraction. However, I can write it as a fraction. What would it be? 6 over 10. Or, what? Could I reduce it? 3/5. Either way, is it in A over B form? Absolutely. What do you think's wrong with number 4? It's a mixed number. Can I change a mixed number to an improper fraction? Okay. So for now, we're going to disregard the negative. What's 2 times 5? 10. What's 10 plus 4? 14 over 5. Now I do have a negative. What did I say in number 2? What do I have to do to that negative? It's got to either be attached to my numerator or my denominator. And now it is written rationally. Okay? I can show that it's rational by writing it in A over B form. Any questions? Anything? All right, we're going to pass over the next example, putting them in order, because I want to have plenty of time to talk today about your number properties. Number properties give us what? They give us what? Shortcuts. Did I say that it's the only way to find the correct answer? No. I said it gives us shortcuts. All right, so in your notes, okay, I did give you notes. However, I do want you to write down this slide. There's nowhere in your notes that I handed out that really gives a definitive keyword for each number property. So just somewhere on your notes, either on your blank sheet of paper or on the sheet of paper that I handed you, I want you to write down the keywords for each one of these number properties. All right, so let's look at each number property now individually. Now, this is the part that you have it right here in your notes. Okay, you do not have to write this down, but you do need to be listening. Commutative properties. What do you see in red there? It says you can add numbers in what? In any order. This does apply also to negatives if you keep the negative in front of the number that it belongs with, okay? And you're going to see more of that in just a minute. But what does this mean? It means that I can rearrange numbers in an expression. It can be very, very helpful in solving. We've already done some of this, right? Where we grouped our negatives and our positives together when we found the mean. You guys remember that? That's commutative property. That's what we're doing here. We're changing the order to make it easier to solve. That's all we're doing here. I give you a very simple example. It's right there in your notes too. Is that the same thing? Yeah. 3 plus 4, 4 plus 3, they both equal 7. What about multiplication? Same thing? Yes. Absolutely. Okay, so it doesn't matter what order we add, what order we multiply, we still get the same answer. Right, Andrew? Okay. All right, commutative property. Associative property says, what do we see in red? Changing the grouping of the terms doesn't change the answer. So let's look at these a little more in depth. Okay, let's look at these examples right here. Order of operations says I have to solve what's in parentheses first. What's 3 plus 4? 7. What's 7 plus 5? Okay, now let's solve what's in parentheses first over here. So what's 3 plus 9? 12. So did it matter where the parentheses were? No. It didn't matter at all. All right, my answer was still 12. Same thing goes with multiplication. 3 times 4 is 12, so 12 times 5 is 60. Guys, it's all right there in your notes. You don't even have to write these down. 3 times 20 is 60 also. So again, doesn't matter where the parentheses are. Here's the catch. As long as it's all addition or all multiplication all the way across. If there's multiplication and addition in the same expression, it doesn't work. Okay? It doesn't work. It has to be all one or the other. That's the associative property. Inverse properties. Here's your key word. What did you write down for your key word? What is it? Opposite. So here's what it means. It says take the sum of a number and its opposite, and the answer is always, what am I highlighting? 0. The answer is always 0. So in the number example, I have 10 plus negative 10 equals 0. Can anybody else give me an example? What would be an example? I have 10 plus negative 10 equals 0. What else? Foundation? 12 plus negative 12 equals 0. Did I take a number and its opposite? What's the opposite of negative 4? Positive 4. So what's negative 4 plus 4? 0. Any number combined with its opposite, right, Xander, is 0. Any number combined with its opposite is 0. Guess what? It applies to algebra too. Any variable combined with its opposite is 0 also. Negative 3x plus 3x is 0. Anybody think of another example? A different number maybe? Negative 6b plus 6b would be 0, right? Any variable term and its opposite equals 0. So the same applies for algebra. All right, so now let's talk about the inverse property of multiplication. 9 over 20 times 20 over 9. What did I multiply by? I'll give you a hint. Look what I'm pointing to. What did I multiply by? The reciprocal. Take any number and flip it. So what is the reciprocal of this? Times 3 over 2, and guess what? They cross cancel, and it's 1. Give me another example.
8 over 12 and 12 over 10.
Times 12 over 10. Does everybody agree that cancels?
Yes.
Yep. What about a whole number? What if I had 7? What would I need to multiply it by? 1 over 7, right? And now, yes, they cancel to 1. They cancel to 1. All right, so you take a number, multiply it by its reciprocal, and the answer is always 1. Inverse property, we think opposites, we think flip it. So what if I had like an algebra term, like 3a over 7? What would I need to multiply it by? 7 over 3a. And guess what? They still cancel. And it still equals 1. So even when I apply it to variables, let's say I had b over c. What do I multiply it by? C over b. And now my b's cancel, my c's cancel, and it's still 1. Okay? All right, inverse property. That's it in a nutshell. Identity properties. Identity properties, whoops, where did it go? Identity properties. When we think identity, what was our key word? Mirror. Identity properties, what do you see when you look in a mirror? Yourself. So it says, take a number and 0, and the answer will always be the number itself. What's 5 plus 0? 5. What's negative 3 plus 0? Negative 3. What is 2,000 plus 0? 2,000. Does it matter what number I use? Take a number and add 0, and it's always the number itself. Identity property. So what number could you multiply by any number, and the number will always be itself? 1. So here, that's what we're talking about with the identity property of multiplication. Take any number, multiply it by 1, it's always the number itself. And it applies for algebra as well. What do I mean by algebra? I mean, okay, what if I had 3x plus 0? What's going to be my answer? 3x. What if I had 5x times 1? What's going to be my answer? 5x. Okay, so it still applies when I use variables. The same rules still apply. All right, you think you can pull it all together? I think you can do it. So in the first section of your homework tonight, I'm going to give you an example. So now we're on our scratch paper. I'm going to give you an example like this. I'm going to say 10 plus, well, I'm not going to use 10. Let's say 13 plus 0 equals 13. I want you to write down what property is illustrated by this equation. And what property is it?
Identity.
The identity of what?
Addition.
Identity of addition. Now you say, well, the addition part, that's a gimme. You won't believe how many people on the test. I have 2 choices on this. Identity of addition, identity of multiplication. How many people say multiplication? So don't take it for granted, guys. Pay attention. Identity of addition. Now let's look at number 2. What if I had, let's say, negative 8 plus 8 equals 0. What's that one? Write on your papers. And then what if I had 2/5 times 5 over 2 equals 0. And 3 plus 5 plus 4 equals 12. And last one, 15 times 1 equals 15. All right, so what number properties are illustrated by each one of these equations? Number 3 is wrong. That doesn't equal 0. It equals 1. All right, number 2, what'd you get? Inverse of addition. Very good. What about number 3? Inverse of multiplication. Very good. What about number 4? Associative of addition. I don't care if you abbreviate the operational word like I'm doing. And then what about number 5? Hold on. Identity. Multiply any number by 1 and it's the number itself. Identity of multiplication. So you have a section like this on your homework tonight. All right, now number 6. Okay. Here's how it all comes together, okay? And here's how it's going to be very helpful to you, especially as we move into Chapter 7, when we start simplifying expressions. I need you to be able to recognize where you see opposites. Let's say I had 12 minus 10 minus 6 plus 10 minus 20. I don't know why I said 12. I meant 20. Okay. So the way that we learned this earlier in the chapter is we said that we were going to group our negatives and group our positives together, right? Okay? Well, maybe there's an easier way. Xander, that's your last warning. Wake up. Okay? So, the easier way would be to look for opposites within the expression. Do you see any terms in here that are opposites? Positive 10 and negative 10. So I can apply, which property says that I can reorder them? Which property? Nope. Which property says I can reorder them? Commutative. Commutative says that I can reorder terms in any order as long as I keep the sign in front of the term. Then I can apply which property says take a number and its opposite and it cancels out. Which property is that? Inverse property. Okay, so here's the commutative. This is the commutative property here. All right, now the inverse property says that these cancel, right? That's the inverse property. These are my justifications, if you will. Inverse property says that I can cancel those. And when I cancel them, they equal 0. What property says that any number combined with 0 is the number itself? Identity. All right? Now, here's what I want you to be able to do. Eventually, I want you to be able to just say, look at them and rearrange them and say, oh, the answer is -6. But you know that you followed the rules because you know that you can reorder using commutative property. You can cancel out opposites using inverse property, right? So it just becomes habit. It just becomes something that's very natural. I want you to try to solve this one. Number 7. All right, so now I've got 35 minus 10 minus 12 minus 35 plus 12 minus 2. All right, try to use your properties now. Use your commutative property. It says that you can reorder them however you want. So how are you going to group them together? Look for opposites. All right, so how'd you reorder them?
35 minus 35.
Yep, 35 minus 35 plus 12 minus 10 minus 2. All right, very good. Commutative properties. Now, what property says I can cancel my opposites? Inverse. Very good. What's negative 10 minus 2? Negative 12. Makes it a whole lot easier, right, than doing all that math? Recognize your opposites, guys. You have a couple problems like this on your homework tonight. Now, what if I threw in some fractions into the mix? Well, I know if I'm adding and subtracting fractions, what do I need? I need a common denominator. Okay? However, when you first look at it, okay, there's no way to add and subtract them without an LCD unless, do you see an opposite? 3/5 and negative 3/5. So instead of going through all the hassle of finding my LCD, I'm going to rewrite it, and make sure you rewrite it on your homework tonight with the opposites next to each other, and then I can cancel out my opposites. So what's 0 plus 5/6? It's just 5/6, guys. That's a lot easier than finding my LCD, isn't it? A lot easier. All right, so 2/3 minus 7/8 minus 2/3. How'd you rearrange them? 2/3 minus 2/3. All right, I don't want to find an LCD if I can recognize some opposites, cancel them out, and what's my answer? 7/8. Or, wait, is it 7/8?
Yeah.
Negative 7/8. Why negative? Because, guys, there's a negative in front of it. You say that's a subtraction sign. Sure. 0 minus 7/8 is negative 7/8. Okay? So, all right. If you understand that, that's everything you need to know, at least for part 1 of the number properties. Tomorrow we'll talk about distributive property.